What you know about math? What you know about math? What you know about math?
I know all about math.
All right, well, here we are with our next installment in Chapter 10 from our Big Ideas Geometry textbook, 10.6, segment relationships and circles. So we're going to be looking at using segments of chords, tangents, and secants. So segment relationships, not so much the arcs and the angles anymore. This time we're looking at the chords, tangents, and secants. We'll have to remember that those are from Section 1. First, let's go ahead and look at a little cartoon of the day. It says, from the New York Times best-selling book, Diary of a Psychotic Baseball Coach. And he's writing in his diary, today I held sliding practice on asphalt. Oh man, that's, guys, yeah. All right, here we are. First thing we're looking at is the chords theorem, segment of chords theorem. So remember, a chord we know goes from, it's a segment going from one side of the circle to the other side, and this doesn't have to go through the diameter. It could be any chords. We're going to have two chords intersecting here. So it says if two chords intersect in the interior of the circle, so it's on the inside, the intersection point is on the inside, then the product, multiplying, product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Well, if you didn't understand that, that's what this is saying down here. So we can see that we have one chord going this way, the other chord going that way. E is in the middle. So we have from basically E to A and then E to B. If you multiply those two together, so this segment on this side, so the distance from E to A and then multiply that times the distance from E to B, that will equal the distance from E to C times E to D. So that's what we know. So we know if we know everything there, then we can just multiply, and they will be equal to each other. Really, we're going to see that's how we can set up some equations, because we're probably going to have to find the value of x somewhere, and so we're going to be setting up equations. We'll see this is what is equal to each other in these segment relationships for those chords. Okay, so here 1 and 2 on the extra practice. Here it just says find the value of x, and this is like what we were just looking at with these two chords. So what we're going to be doing is multiplying this side of the chord times that side of the chord, and set it equal to multiplying this side of this chord times the other side of that chord. So for this first one, we'll start with the x side. So we're going to say x is being multiplied times the x plus 1, and that will be equal to 5 or 6 times 5, which will give us 30 on this side. So we're just going to distribute this x in, so it's going to be x squared plus an x is equal to 30. And this is a quadratic equation, so we want to set it equal to 0. So if we haven't solved quadratic equations in a little while, then just use this as a reminder and review of how to solve a quadratic equation with factoring. We're just going to need to use really factoring when we see quadratics in this lesson. You can always use quadratic formula if you need to, but I don't think that's necessary, because we should be able to factor these. So we could just subtract the 30 then from both sides. So now it's going to say, when we subtract 30, it's going to say x squared plus x minus 30, and now we want to factor this to two binomials. The x's will be up in front, and when we want to think about what two numbers multiply to give us 30, that subtract to give us a 1. Well, that's going back to just 5 times 6. So our two binomials will be this here. So the x's are up front. 6 and a 5 are the two numbers that multiply to give us 30, that when they subtract, they do give us 1. They are different signs, because it's a negative 30. They have to be different in order to multiply and get a negative 30. The bigger one, 6, is going to get the sign of this middle term here, x, which means 5 is negative. So now we're going to set each of these factors equal to 0 separately. So it's going to say x plus 6 is equal to 0, and x minus 5 is equal to 0. And then we're just going to subtract 6 on this one, add 5. So when we subtract 6, we get negative 6 and positive 5. Now that's two apparent answers, but we can only keep one of them. The only one we can keep is the 5. So the only answer to this is 5. Even though we get two apparent solutions of this quadratic, we can only keep the 5 because it's positive. We cannot have negative lengths of things. So if I said negative 6 goes in here, and this is negative 6 here, that would make this into a negative length, and that's not possible. So our lengths, our distances, the chord has to be a positive number. So that's why we can only keep 5 as an answer. All right, let's come over to try this next one, number 2. So we're going to start with, let's start with the 15 chord here. So 15 times this binomial on one side, so 15 times the 5x minus 2, and it's equal to the 10 times the 7x, or the 7x times the 10, however you want to put that down. And so now you just multiply in with the distributive property on this side. That gives us 75x here minus 30 when we distribute 15 into both of those. Multiplying 10 times 7 is 70x there. So now we can subtract 75x from both sides to get the x's on one side. So I get negative 30 now on this side here is equal to negative 5x. And we just divide by negative 5, and that's going to give us negative 30 divided by negative 5 is a positive 6. And so that does work. We can keep that number at 6. It does make everything positive in here for our chords when we actually plug it in. Okay, so that was just talking about the chord segment. Now we're going to talk about the tangent segment and the secant segment. So the tangent segment is here in blue. As you can see, it's connected to S there, which would be a point of tangency. Now it doesn't keep going, it just is this one segment here. That's why it's a tangent segment, not a tangent line. And so it's just this one segment here, and then this other segment going all the way into it, so it keeps going all the way in through the circle. That's a secant segment, and a part of that segment you have is an external part of this secant segment. So that's what these are for. You can go ahead and highlight these on your core concept, because these are the vocabulary words. So tangent segment is a segment that is tangent to the circle at an endpoint right there. And a secant segment is a segment that contains a chord of a circle and has exactly one point outside of the circle. So there's the chord that it contains, and there's your external segment, and it's containing this point P on the outside. It says the part of the secant segment that is outside the circle is called the external segment. Okay, so let's just understanding the terminology of that right there. Let's keep working on the next part. So we look at another theorem here. So segments of secants, that's right there underneath that on the same page. So we have two secants. So you have the E is the external segment going through here, two secant segments. So what we can say for this, it says if two segments or two secant segments share the same endpoint, so these two are sharing both E here, outside of the circle, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segment and its external segment. So basically it's this here, it's the little external part, that little part that's in red, EA, times the whole secant segment from E to B. That is equal to the same thing on the other secant segment. This little external part, E to C, times the whole thing. Okay, so that's another thing we can also know that is equal to each other, and looking at these segments here. The next one below that is now the segment of secants and tangents theorem. So now what if we have a tangent segment and a secant segment in the same circle, or on the same circle, and it's kind of got the same similar property. So it says if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So basically you look at that tangent segment, the E to A, and there's nothing to multiply, it's just one segment. So what you're going to do is you're going to multiply it times itself. Square it, EA squared, which means you're going to multiply that times itself. And then the secant segment works just like the last one. It's the external part times the whole thing. So this times itself, or that squared, is equal to the external times the whole secant segment. So another thing we know about how to set up some equations and making things equal. Okay, going back to page 307 on that extra practice, the 3 and 4 problems now. So this one, it almost looks like this is a tangent line. It actually is not. It's just barely going into the circle. You can see that's what that 1 is for. There's a little chord right there. Your external segment part would be right here. This is the x plus 2. So this is two secants. This one's very clear, but this one was a little harder to see. That is a secant as well. So that means that we're going to just basically set these equal to each other. Let's start with one of them. It doesn't matter which one we start with. So the external part on this one, let's start with this one, we can clearly see the external part times now the whole thing. The whole thing would be adding these two up, right? A little segment addition. X plus 3 plus 2, you just combine like terms, that would be x plus 5. So it's the 2 times the x plus 5, and that will be equal now to the external part, x plus 2, times this whole thing here, which would be adding this up. So it's just going to be adding 1 to a 2 here, it'll be an x plus 3. And so here we're going to distribute this 2x. It's become 2x plus 10 on that side when we distribute, and it'll be equal to doing FOIL over here. So x times x on the outside will be x squared. The outside and the inside, well, those will be added together. So we're going to say outside's 3x, inside is 2x. That makes a 5x from the middle. And then the 2 times the 3 will give us a 6 at the end. So that's just doing a little FOIL to get our trinomial here. And so now we're going to kind of maybe bring things over. So I'm going to subtract this 2x. I'm going to subtract 10 from both sides. Cancels them on this side. Brings them over to here. I do have a quadratic now, so I just have x squared. These two combine to give me 3x. And this combines to give me negative 4. So I now have x squared plus 3x minus 4 is now equal to 0. We're going to factor this again with two binomials. X goes up in front of each binomial. Two numbers that multiply to give us 4, that subtract to give us 3 would be just 4 and 1. So we're going to put those numbers in there. So our x's are up front, 4 and 1. And they are different signs. The bigger one, 4, is going to get the positive, which means 1 gets the negative. And so now each one equal to 0. So x plus 4 equals 0, x minus 1 is equal to 0. And so with this one we're going to get a negative 4, and on this one we're going to get a positive 1. So again, we're not going to keep both of them. We're going to get rid of this negative 4 because it is negative. If we were to plug negative 4 into here for x, it would make negative lengths, and we can't have that. So that's why you can't use the negative 4. So negative 1 is the only answer for that one. Now, problem 4, this definitely is a tangent line. You can see right here. So here's a tangent segment, not a line, I should say. It's a tangent segment. Here's your secant segment right here. So we can say that the tangent segment is going to be multiplying itself. So x plus 1 squared. So we'll do that, and that's the same thing almost as doing them times each other, or x plus 1 times another x plus 1. On this side, it's going to now be equal to the external part, this x minus 1, the external part, times the whole thing. So we're going to combine like terms here with negative 1 and 5. That makes x plus 4. So now we're going to multiply these two binomials. We can think of this as also two binomials on this side if I want to kind of get rid of my square here and just see it as 2x plus 1s. That might be easier for you to do FOIL with. That's okay. So since it's multiplying itself, you can write it out like that and then just do FOIL. So x times x is x squared, and then the outside is 1x, the inside also is 1x, that makes 2x, and then 1 times 1 is still 1 in the end. It will be equal to, on this side, x squared again from the first terms. Outside's 4x, inside's negative 1x, so you take 1 away from 4, it gives you 3x, and then negative 1 times 4 is negative 4. So now we're going to, see that we have x squareds on both sides. So what I can do is I can cross those out. I have x squared on this side, x squared on that side. They're exactly, if I were to subtract 1 from both sides, I would cross them out anyways. So those cancel each other out. So now I just have this equation. So I'm going to go ahead and start solving for x here. Let's subtract 2x from both sides. Now it gives me 1 is equal to an x minus 4. Just add 4 to both sides. It's going to give me 5 then for x. So our answer for this one is just 5. All right, so let's go ahead and look at a little joke of the day for today. Our joke of the day is, what do you call a dog underwater? What do you call a dog underwater? A subwoofer. Subwoofer. I said it real deep. All right, well, there's more to this lesson. I know we finished the extra practice, but I'm going to have you go back to page 305, I think it is, and we're going to do a few more problems. Okay, so on page 305, we're going to do a few, you're going to do these problems yourself and practice them. There's a lot of space on 305 because we didn't write anything at all on this page. So you have all the space on top where the vocabulary is, that's all empty there, and then below that, theorem 10.18, that's also empty down there. So start at the top, and then you can start working your way down. We're going to do about 7 of these. So go ahead and do number 1 and 2. Go ahead and try both of these using that first theorem we were talking about, using the theorem that's even on this page right there with the chords. So do that and then go ahead and play it and then see the answers. Okay, so hopefully you've done these now, you've maybe copied them down, and you're ready to now see the answers for these. So for number 1, our answer for this one is 8. And so we could see that's going to be 8 there. And for number 2, our answer here is 5. So if you didn't get those right, here's how you should have done these. So number 1, you're multiplying 3 times x, this chord here, and the other side is 6 times 4, which is 24. So just 3x is equal to 24, giving you 8. For this one, you're going to see you're going to be multiplying this 2 times x plus 1. That's a distributive property. Eventually gives you 2x plus 2. You're also going to set it equal to multiplying 4 times 3, which gives you 12. So you subtract 2, and then you divide by 2 to give you that 5 answer. Alright, so now go on to 3 and 4. Okay, so on 3 and 4, do the same thing. Go ahead and try 3. 4 is quite a bit harder, so you may want to, if you get stuck on 4, just go ahead and play the video and I'll show you how to do it. But definitely you should be able to do 3 fine. So go ahead and try 3, stop the video, at least do 3, and then check it, and then you can maybe watch me do 4. Okay, so hopefully you did at least 3 here. The answer for 3 is 13 for x. That's what you should have got for x. The answer for 4 is 3. And we'll see how to do that one. If you didn't get that answer right, or you just weren't sure what to do, that's fine, because let's go ahead and watch them. But to do this one, remember these are those secant segments, and so you're going to be setting these equal to each other. So the external part times the whole thing, and so that's what it should look like here. So 5 is the external part. The whole thing would be just x plus 5, just adding those up, equal to 6, the external part, times the whole thing, which would be adding 9 plus 6. That's a segment addition, giving you 15 there. And so then you distribute that to 5x plus 25. This makes 90. Subtract 25. And then you divide by 5. And that gives you that 13. 65 divided by 5. Now number 4, this one's a little more challenging. We're still going to set it up the same way. We'll start off with 3, the external segment, times the whole thing. So this is going to be an x plus 5 there. And then the other side is going to be the x plus 1, the external segment, times the whole thing. So when we add x plus 1 and x minus 1 together, then the 1's will cancel each other out. So we're going to get a 2x, and that's it. So that's why it's x plus 1 here times the whole thing added up is actually just 2x. So it's a distributive property on both of these. So you distribute this one, you get 3x plus 15 over here. This side you're going to distribute 2x, you're going to get 2x squared plus a 2x. And it is a quadratic, so we're going to get, I'm going to bring these two terms, I'm going to subtract 3x, subtract 15, and bring them over to the other side. So when I do that, I'm going to end up with a 2x squared minus an x when I combine the x terms together here, minus x minus 15 equal to 0. We always set it equal to 0. And now this is factorable. It's factorable with the star method though, so if you haven't been familiar with that or not shown that, I'll show it to you now. But we need to get this into 2 binomials, just like before, but it's a little more difficult when you have a number in front of the x squared term. So I usually just use the star method to do that, and that's what this is over here. Put an x down and a line across the middle. And so we do a top part first. That's going to be negative 30. We get that by multiplying the first number times the last number. So 2 times negative 15 is negative 30. Then we do the bottom number, that's negative 1. We get that just from the middle number here. The negative 1 there goes down here. And then we do the top of each side. It's 2x on both of these because it's just the way this kind of trinomial begins. It comes the number and the letter. Just put the number and the letter of how it begins on the top of each side. And then the numbers down here are the last part where you ask yourself what 2 numbers multiply to give you 30 that subtract to give you 1. And that is a 5 and a 6. And so they have to be different signs. The bigger one's going to get the negative from this negative 1 here. So 6 gets a negative, 5 gets a positive. Now right here, 2 and 5, you cannot reduce those, but you can reduce 2 and 6. So really this is going to become just a 1x. This is going to become a 3 when I put it into my binomials. So my 2 binomials will be over here just like this. The 2x plus 5, that's actually a plus, it almost looks like minus, I'm not sure what happened there. This should be 2x plus 5, and then an x minus 3. That's from simplifying this. Now, dividing each of these by 2 makes this x over negative 3. And so now we set each one equal to 0 separately. So now there's the plus. You can see 2x plus 5 is equal to 0. And I'm going to subtract 5 and then divide by 2. That would give me a negative 5 over 2. This one you just add 3 and you get 3. Now we can only keep this one because this is a negative number. When we plug that in, it would make a negative segment, especially right here on this secant. So the only number you can keep is that 3. That's why the answer is just 3. All right, we're almost done. Just 3 more problems on our page 305 here to do. Okay, so 5, 6, and 7. Just going to have you do these 3 problems. Again, still finding the value of x. This is when you have a tangent segment and a secant segment. Okay, so go ahead and do the same thing where you have to remember squaring or multiplying the tangent one by itself, and that's equal to the secant, the external times the whole thing. So go ahead and pause the video, do 5, 6, and 7, then play the video to check your answers. Okay, so hopefully you've done 5, 6, and 7 now, so let's check to see if you got these correct. So for number 5, here's how you should have done that. It's just going to be the tangent segment squared, so x squared is equal to 1 times 4. So 1 times the whole thing. The whole thing is going to be 4 because you're going to add up those 1 and 3. And so you're going to take the square root of both sides here for the x squared. To get rid of the x squared and make it just an x, you take the square root. So square root of 4 is just 2. So our answer for this one is just a 2 there. Number 6, here's what we're going to be doing. 7 is our tangent segment part, so that's going to get squared. So 7 squared is equal to the external part, the 5, times the whole thing. So it's just going to mean x plus a 5. So distribute that into there. So 7 squared is 49. It's going to equal 5x plus 25, and subtract 25. That gives you 24 equal to 5x. Divide by 5. And so we get a decimal answer for this one. 4.8 is our answer for number 6. And then for number 7, 12 is the tangent segment. So that's going to get multiplying by itself, or squared. So it's going to be 12 squared is equal to the external part, which is x here, times the whole thing, which would be x plus 10. So you distribute this into here. 12 squared is 144. It's an x squared plus a 10x. So this is a quadratic. We're going to have to subtract the 144 to both sides. So that leaves us with the x squared plus 10x now minus 144 equal to 0. And then we factor this to the 2 binomials. So the x's are up front, and then you have your 18 and 8. Now that one might have been a little harder to figure out. 2 numbers that multiply to give you 144, that subtract to give you 10. You just have to kind of go through your different factors of 144 until you find one that would work. Find one combination that would work, because it's not 12 times 12 or something else. It's 18 times 6 is 144, and if you subtract those, you get 10. And then they're different signs. The bigger one, the 18 is positive, which means 8's negative. So we're going to get a negative 18 and a positive 8. We're only going to be able to keep the positive number here because we need to make sure we keep a positive segment going on there. So 8's our final answer. All right, so that concludes now 10.6. Go ahead and finish up your assignment, and I'll see you in class.